Page 82, question 3. 3a, principle of conservation of energy. In a process, the total energy before the process is equal to the total energy after the process. Part B, define work done by a force and state unit. Work done equals force times displacement in the direction of the force. Force times displacement in the direction of the force. And then the unit is, of course, joules. Work done is joules. 3 part C, we're getting towards some calculations now. First one, though, is what is one major energy transformation in this meteorite which hits the Earth. It starts off with kinetic energy, so you can have kinetic energy turns into either heat, that is one possibility, or kinetic energy turns into sound, or indeed kinetic energy turns into elastic potential energy as the ground is changed shape. There's elastic energy there, so any of those three would be correct. Part 2, show the initial impact speed must be this value. So we use our formula for kinetic energy. Kinetic energy equals a half mv squared. We've got to rearrange this and make v the subject. Probably easiest to make v squared the subject to start with, so v squared equals 2kb over m. And we'll carry on and work out v squared, which is 2 times kinetic energy, which is 8.4 times 10 to the 6th joules, all over the mass, which is 3 times 10 to the 8th. And we get an answer, therefore, of v squared to be equal to 0.056, and then v equals 0.24 meters per second, which might seem like rather a small number. Is in fact 0.4 meters per second. 0.24 meters per second is around about half a miles per hour, so that's very slow. And what's happened here is there's actually a misprint in the book. If you look in the answers, they've used the value here of 10 to the power 16 and not to the 10 to the power 6. So in actual fact, if you do that, there must be a misprint in the question. If you do that, you get v is not 0.24, but actually 24 times 10 to the 4 meters per second, which is much more realistic. It's a very high speed collision. So there's a misprint in the book there. Clearly that wouldn't take place in your exam paper, but here's the correct technique here, and here's the answer you get if you use the correct figures as well. Part 2 then, coming up now, show that the initial impact speed of the meteorite was about, oh sorry, we've done that. Part 3, I do apologise. Part 3, the crater is 200 meters deep. Estimate the average force acting on it during impact. Well, we know that work done is force times distance moved, or force times displacement. We want to try and work out the force. Rearrange here, force equals work done over displacement, or distance. The force operates over a distance of 200 meters. The work done is equal to the change in kinetic energy, which we know from the data here. In fact, this figure here is a change in kinetic energy. So force is work done over distance, which is 8.4 times 10 to the 16 joules, divided by distance 200. If we work those out, we get an answer of 4.2 times 10 to the 14 newtons. The force is measured in newtons, so we get a rather large force there for that one.